helping. Is that any better?
That it's definitely better. Oh, that's better. Yep. Now I can read the
Yeah.
letters.
Okay, good. You can read it anyway. So look
Yeah.
at we'll just take one simple one.
Sure.
This was all kind of the left single expression. These were all into loads of different methods. I just combined them into one, so it reduces the amount of fucking code you have to look at in your editor.
Sure.
These are all different kind of expressions. There's binary expressions and all that kind of jazz. But it's I switch on whatever one of these it is in the method. I'll show you the method after, and then you can decide what it is.
Okay.
But I added these. If you added like left equals single expression, and then op equals one of these bad boys, and then scroll over the other side. Right equals right, single expression. This should be uppercase. Remember that. Otherwise, you have to use a. I fucked up there. Yeah. So this corresponds to left-right expression. So if you go into, we go into my implementation here and the examples, and we go to. It's an expression. So see, these are all everything you see there with a pound and the name that turns into visit whatever the fuck node, visit assignment expression, visit identifier expression. So you get all those, and you can either work on them as you get them and extract their children, or you can call the visit children method, which is what I use here, and that then you can kind of switch on the type and do whatever stuff you like. There's a million ways to implement it. This is just one way. It really depends on what you're trying to achieve, to depend on even whether you use a listener or a visitor. Let's get that visit assignment expression. So this corresponds to that visit left right expression. Okay, so we get the context, and it's a parser left right expression context, which basically has an op field, which is a token, basically an op token. Each time you assign it, you're assigning it to a token. So just I could also use expression or get expression and then the number of the expression, but I just find it easier to give it names, give a token name, so then it just corresponds to like left and right, and it's just, I think for me it reads easier than trying to be get child 0 dot fucking whatever. This is exactly what you want it to be. So that's we switch on the op there, and it's either a binary expression or a logical expression, and then we panic because it should be one of those. So then you create this expression object, and we have the op, the left, the right, and the source info. Basically, I can go and look at that. This is kind of what ES3 does. I was starting to do it, and then I realized afterwards this is what to do. So I kind of have it implemented somewhat. So this kind of gets creates a source info object. So you get the line number in the source file. Then you get the start index and the end index. That's where the beginning of that line is. And this is the whole line, or the whole. It's not just a token. This is everywhere. You can have it like if you had an import statement, it'll give you from the beginning to the end. If you have the from in part, it'll give you from the beginning of the from to the end of the from. So you can manipulate little sections by operating on those. And this gives you the original source line. You use the input stream, getting the interval from the start to the end to the stop +1, because obviously your indexing it stops at you need +1 at the end to get the full line. So basically, so if you had import foo from bar, that would give you on line 10 0 column to the 20th column, whatever the fuck it is. All that information is there. So you get the original source, you get the token, and you can either directly, the way I have it set up, they're on the visitor types, they're pointers. So you can directly manipulate it and then extract, do .code on it, and it'll actually show you the manipulated code.
Okay.
Which is like with that. I don't know if you've seen Rich Harris's "It's Code Red" or something. He has something similar. If you look at his thing, you can actually. I found he had a leading X, and then he had fucking what do you call the ticks for like string templates or string substitution in JavaScript, and he had this leading X. And I was like, what the fuck is that? Couldn't understand it. I was like, what have I missed? No, nothing about JavaScript, but it's this code red stuff, and it basically manipulates. It allows you to manipulate source code, and he creates a kind of a program for the parser for an AST out of it as well. But that's kind of the similar idea here. You'd be able to manipulate just a particular token. You can change its source, and then you can when you do 1 second, let's get back up here. I'm confusing you. So this is the source info object that I've embedded. It has a start, end, the line which are integers. It has the source, and it has a children, which is, forget about it for now, they're not implemented. And it implements the vnode type, so it's satisfied a certain intervals. This is going to be like the base node. Every node will have this information. It'll have the start line, the end line, the original source, and the only way they'll differ later on is by specific types. So you'll do like you'll do a type check, and is this like an import statement? Is this a declaration? Like they'll all have this thing. So this is the base node. They'll all inherit from this in terms of like from other languages. But they're composed of source nodes, and this is an expression. There's various types of expressions. There's a fucking visit property assignment expression, visit computed property assignment expression. We can create all these, we can map them directly to that ES3 thing that I showed you, that I accidentally showed you, but you can look at it, and if you just Google ES3, you'll see all these interfaces. We can use all these methods as we visit to create those interfaces and attach them onto the visitor type. This is what I created. This is something you implement. The base parse JavaScript visitor satisfies a certain interface, which is what's needed for in the parser itself. So it's by embedding one of these, you technically have all the methods, but like I showed you before, they go back to an ANTLR parser and it returns nil. So it's a no-op. So say if you only wanted to operate, like I said, on declarations or whatever, the small subset, you only have to add those visitor methods that are relevant to that. But they're all listed here on the base visitor. See, he implements everything. And this V goes back to the actually original ANTLR.3. It's another interface that has a base implementation, so that returns nil. But everything here, when you create, I actually have code in the repository there that if you run the main thing, you give it, just use the name parser, and because you have to post process some of these because they're the code that generates them has some mistakes in it. So I actually have them implemented, so you can recreate this locally. I'll show you after. Just run the go main file with what's there, process it on the fucking G4 files, and then just pipe it after to the go main thing, and it'll create everything for you. And this is what it'll spit out. It'll spit out a parser. It'll create this parser object. It has everything you need to implement your own visitor. So everything but all the methods you're going to care about, all you give a shit about is what's in here. Visit program, visit source element, visit statement, visit block, visit statement list. Then you basically, I'd say on my visitor type, I v visitor, and I implement that, and that gets called, my implementation gets called when I have it implemented on my type, on the visitor type. So you can manipulate just that certain subset of the tree, or those specific things you're interested in, and just you'll still have access to the original source code. So like I said, if you want to make changes, you'll have your start point, your source node, it'll have your start, where it begins, where it ends, the line it's on. So you can extract those. You can say remove those from the original source and put them into your transpile stuff, and everything else that you've no interest in, just leave as is. You don't have to manipulate those bytes at all. But this will 100% correspond directly to wherever the offset is in the bytes. It's 100% accurate. So you can remove stuff, add stuff, and manipulate stuff just by using the source, the line number, the index, the column index, start index, and end index. But yeah, basically, you don't need you can just pull this down and leave this as is. You don't need to implement anything. Everything is there that you need. We don't need ANTLR again. This is just if you wanted to make changes to the grammar file. You'd have to rerun it again. Sure. But as it stands, you can pull that locally. You can go into the examples folder here, and you can fuck around with the visitor methods, or you can implement more visitor methods that I haven't done and manipulate the source any way you want. You can go in quickly here and have a look at this. So this does, say this is the import. Some of these aren't 100% working because I just hadn't got time to totally do it. But all this kind of stuff, it'll accurately get all these. The only one that'll have an issue with is the await and the promise, because it's a combination of two things. Sure. It's a direct declaration and an expression. But you can run it down. You create the parser from your stream, which is just text that's coming in. And this text here, new common token stream, just ignore that stuff. You're just passing in the lexer. You basically parse it, you lex the file, you get your tokens first. All these become tokens. You pass the token stream into the new common token stream. And then you parse it, and then you can start at p.program. You can start at, they all map to different things, like what else was there? You p.program, maybe p.statement, whatever is on the top left-hand corner of the parser file. Let's see if I can get the fucking thing up here. You can start. You can see the very first thing up here is program. That's what p.program corresponds to. So if you wanted to start at the source element, you start there, or source elements, you can start there. If you want to start just at if you knew there was one statement, or if you wanted to say, if you knew there was one expression, you would just go p.expression, and it'll start there, and to just pull that expression, and you can manipulate that and work on whatever the fuck you want to do with it. Just what I actually do down here. One of these is a single expression.
Mm-hmm.
But basically, I've created those types, and as you iterate over all the nodes, the way I have it implemented right now is any nodes I'm interested in, I append them to a slice. So you'll have the type here. If it's an import declaration, we do the fucking conversion basically. Then I can implement the id.import from. I can set it to whatever the new path. If the module items exist, I can have the alias name. I can take the first one out and change the identifier name to whatever the fuck you want to do, and you can run it again, and you'll see the changes. So we'll just run that one with the imports, and you'll see the before and after, and you'll see how easy it is to manipulate.
Sure.
Code here. If I can get back up here, like this is a mess, but this is like I'm fucking just. I get an idea and then I just implement it.
No, that's
There's
great.
no real science behind it now. It's
Yeah,
just because I'm still figuring it out myself. So we'll clear it here. If you can see my terminal.
Yes.
Make this bigger. Where are we going here? If I fucking manipulated this at all. I'm trying to operate in the pointer type. Oh yeah, no, I haven't fucking. I just realized I changed something there. Yeah, but it will be that easy. It did work up until I changed something a few minutes ago because I just realized I don't have a pointer anymore. I need a pointer. But that's it. Basically, for an expression, this was another way I was doing it. The alternate option, you could put the imports in one thing and put the expressions in another.
Mm-hmm.
Each time you encounter an expression, then you'll have access to expression.left, expression.app, the right, and expression.source, or you have all the line information. So you can either build your tree of nodes, the base node type, and then do your type checks on them, or maybe you could put, like this is an expression slice. So you could just put all your expressions in one, and maybe all your declarations in another, and all your imports in another. But that's like, as down the line, you can decide whether you want to segregate them out, so you know what you're dealing with straight away, or you just want to run through the tree as many times as you want to run through the tree. That's just the two different ways of doing it, really. There's no right or wrong way. It strictly depends on what you're trying to achieve in the first place.
Mm-hmm.
But this technically should be the way it is. You can iterate over the expressions. You can get like get the info, gets the source, the original source. You can show the original code. If I wanted to change the left expression to 100, I'll go v.left equals 100, v.code, and you'll see that that's manipulated the code any way you want. So basically, if you name all the tokens and you say map the tokens to your types you implement, you can just access that token, manipulate the code, and then any way you want. So if we were looking for, say, take our import example, trying to find the path, we would extract the import from piece. We'd look first, and then we'd go import from piece, inject it back in, manipulate it, and then just print out the source, and you've got it changes. Like v.code will be before, v.code after will have the v.left change to 100. So that's then you just export all that to another file. So it's really easy to manipulate little bits of it because you pull the token you're interested in, you change it, you set it whatever way you want, and then that's it. You're done. So you can imagine how you could transpile anything really in JavaScript because it tells you the type you have, the fields that are available, what you need to change. So it's literally that simple. You iterate over, you check for the type you're interested in, you manipulate the field you want to manipulate directly because they're all pointers, and that's it. You go and print out the tree, or you print those things at the end of your manipulation. You iterate again, and you print out all the codes, or you store the code as you iterate in a list. Like pull out this import, pull out whatever, manipulate it, put it away, and then print it to files, whatever you want to do. So it's actually really easy to change stuff. So you can see how this could be like your imagination is the only thing that's going to fucking stop you from here, because you have access to all the tokens. They're all named exactly what they are. You just manipulate them as you see fit, and the bytes are changed as their pointers, and then just put them wherever you want to put them.
That's
that's
great.
I hope that made some sense and it didn't confuse you even more.
Well, no, I mean, obviously, I think there's a lot here that I need to spend a little time learning about, but I think that makes sense at a high level, and it's cool because right now I know we're like going through and refining those import statements with regex, which in like an SSR component, there's a lot of like CSS information and maps and things like that you have to try to get through. So sometimes the regex picks up some weird stuff and there's all these weird bugs. Something like this would work way better, which is cool. And then, so right now I think we're basically trying to find those imports, and then we're like converting those into, we're commenting them out because V8 can run them. And then we're converting all the references to those to like these component signatures is what we're calling them, right? So like eventually we wouldn't have to do that. We could actually read these things as they're meant to be read, which would be pretty cool. So this is awesome.
yeah, look at it. Like I said, there's a very high level look at it, but it's really it's as simple as that. Once we have implemented the ES3 types and you know exactly all the fields, it'd be really nice for your editor. Like here, you have module items. I know what I have. Like I know it's module items, so I know I have there's alias names. You've all the access to the fields. It's really fucking easy. Even if you don't know anything about this, you have a decent editor, it'll give you access to what you have to work on. So like it's very like intuitive. Like it's like the alias names are alias names, module items. There may be one or none alias names in it. If their alias names is not 0, then you know that you can manipulate the alias names. It's like it's not complex. Like anybody, if you've no idea about parsers, you don't need to know anything about parsing. You just need to be able to fucking read English basically and know that what module items are. So if we name everything, use the ES3 syntax, name everything the way they do, it'll make it very easy for anybody then to go, okay, this is what I know the types, this is what I need to manipulate, this is what I need to work on, and there's no real learning for anybody. Sure. Anybody can read the types and go, this is what I have. You can iterate over the tree, and all you're literally doing is you're checking for types. You're like here, make sure you're saying this is an import declaration because I know a v.type is here. Like you could just do the switch anyway, but I just thought it's easier, and it's also what ES3 does is they tell you the types. You have a text, you have a string there, so it's just like I don't know which is better, but at least you know this way. There's no type checking. You're 100% certain that it won't panic. So there you go. And you don't need a OK ID equals to whatever, and if it's not fucking whatever, do whatever. Sure. Just we know this is the type you have. So we're gonna work on an import declaration, which we go to here. Shit, import namespace. Basically, what these are, I'm just taking the things from the file, from the grammar, and then mapping them directly to objects. That's like that's as complicated as that's going to get. So we go up here to the old import expression that I just fucking went to a second ago. If this is the import default, obviously an import default can have a alias name, which is an alias name, which is an identifier name and potentially an alias. Like not every alias name has an alias. It's like this is basically you combine the things together. Back up to here, I should really put these together. Import expression. Like an import expression is this here. It's an example here. Import single expression. So again, you embed all the source info. So you're always like that gets source info, updates that node with all that information, and then it's just a single expression. So basically, you have the import and the single expression is in here.
Oh yeah.
So again, you've another token to manipulate. Forget about this stuff. You'll add that back in yourself. They're just terminal nodes. So if you wanted to print this, or if you wanted to print this code object out, you'd have to add these bits back in because they're terminal nodes. We don't care about them. But if you want to operate on the token in the source code, you'll extract that token. You'll have all your offsets, your line number, your start index, your end index, and you can manipulate just that single part of it. So once you found an import expression, you just go in and change the content here by simple v dot whatever node dot single expression equals whatever the fuck you want it to be now. And that's it really. All these code and types things are just to satisfy the vnode interface, so that at least you can always get access to those without any type checking at the time. The main, let's go to visitor. Actually, maybe we should start it here. So this is a visitor. Just forget about this. So these are the different approaches. So you say they're all v nodes. We can create a tree just v nodes to satisfy the code, get info, and the type. They're the three methods you need to implement to satisfy the interface. Okay. So we're appending all those. So if we wanted to append everything from the tree, we could just make them all v nodes, satisfy the interface, and then iterate. But again, if you wanted to say separate your imports, you could have an import type here, and then you know exactly that you have imports. There's no type checking because you know you have import types. If you want expressions, put the expression types here. If you want declarations, put your declaration types here. So you can either split them out, like this is one approach, or this is another approach where each specific type gets put into its own list of its specific type. So like I said, if you wanted to operate on imports and declarations separately, you would just, as you go through visit children, you would switch on the type to decide what the results is. That's just saying, right, this is the results is an interface. This is the context. See, all these things, the fucked up part of this is the context is many things. That's why you have to satisfy many interfaces, like you're an ANTLR parse tree, you're a rule node. There's loads of different things that you are. But once you understand that, it's very simple to to do whatever you need to do. So here we're taking in this and we're just deciding what the node type is, and that'll give us the results. Now going to be a list of expressions or a list of import declarations, and then we iterate through here. These are all the children. You pass down the context, we iterate over your children. This accept method is basically just, yeah, I'm accepting it, and let's visit it. Let's continue the visit. You know, let me keep going, recurse across the rest of the children. So if you have an expression, we're obviously, we now have an expression list, so we're going to append to that. If we have an import declaration, we're going to append to that, or we just have a V node, we're going to append to that. So then basically you return result. So then up in the parent node, when you get the result back from visiting your children, you confirm this is whatever type it is, and you can append it to that one. You can spread it to your, any example here, I don't think there is actually an import visitor. I think there's one in the import here, maybe you can see. Up to stop. It's a lot of code.
Yeah.
Yeah. So there you go. This is v.nodes. Because we know we've already checked down below that this is when we're visiting from an import, this is the context that's getting passed to the children. So we know that we are this type. We are an import statement context type. So when we do the switch, the check, or the import declaration, whatever you pass down, you will know, you can check the type of the context that's coming in and do the appropriate action after. So whether that's like saying create an import declaration, or a list of those, or a list of expressions. So you can either centralize it in one place, like the children method, or you could just basically do it all here. If you're a top level node, like an import from block, you have just children then. You're like you are an import statement, but all the good stuff happens here. You could just work on all the stuff here, or you could call ctx.children and the rest will happen. And on each one, you would append an import default if it was there. You would append module items to there. You know, you do the switch in the v.children and you'd append one of those and you'd build it up that way. So you have each individual nodes, or you can do all your work here. We do a check here. If the import is not default is not nil, that means it is a default import. So we operate on that and we extract the node back from that. If it's module items is not equal to nil, we do the same thing. We then visit module items. So yeah, you can either take the top level node and decide what's nil and not nil and set your fields here on the object, or you could just do visit children and append each node and subnode individually and re-put them together later on in the tree. So you have a tree from top to bottom of each little individual token, each node created, or you can just kind of amalgamate them into one and say, like one that has 5 children, you have that one and it has 1 to n fucking fields. They may have maybe an import default, they may have module items, they may have whatever. You can do the logic here and decide. These are just again fields on the import declaration type. So like I said, you can either manipulate them at the top level, with the highest one up the tree of that subpart, like the import from basically maps to, let's see, import from. See, the import statement has an import. This is just terminal node. That's the actual word import. So after the import, you have import from block, which is here. So this has an optional import default, and it's either import namespace or module items, which map to those objects I have, and map to this here. I basically create a module items object that works on this logic and works off this logic, and then it has the import from, which is basically the path. And EOS is like an EOF or whatever, or a semicolon. So that's this import from that you see here, the lowercase, that directly relates to the uppercase import from that I checked off the context object, CTX and import from. If it's not nil, that means the import default is not nil. That means this is actually set. So then you do the appropriate action. You extract the information from that. If the import namespace is not nil, that also means that's set. But one or the other, you're never going to have both of them. You can't set an import namespace. The pipe is just R basically, and this is optional. One of these has to be here, but it's one of either. If it's a pipe, if you have a question mark, it's like can be here, cannot. It doesn't have to be there. It's totally optional. This is always here. This is the path, like import from whatever the fuck path is there, and that's the end of that. But all these directly relate to change that to an uppercase, and that's on the context object. That's on this import from block context object. When you would do the visit import from block, you have access to all this stuff on the context object. Even if it's nil, it'll still be there, but the fact that it is nil, you know it doesn't exist. There's nothing there for you to see or visit. So then using that information, if that's not nil, you can create your import namespace object and pass in the context of that down. This has a visit import namespace method. There's one there as well. That takes a context object. So if you do this object, this context.import namespace, pass it down, then that has the right context. And then you just continue down the tree. So you're just passing one context to the next, to its child. Like that when visit children goes, you're accepting it. You're at a higher level, higher up in the tree, it's deciding what you are basically. It does a switch in the parser and it goes, okay, your module items we'll call v.visit module items. And it's the same with all these things. But yeah, everything you see here maps to visit, whatever the fuck, and then anything in here, this with an uppercase, this is actually a terminal, this is a string. That's all that means, the uppercase one. This lowercase ones means that you have import from on the import statement object. So you could go visit import statement, that context would be the visit import statement context. You could do context.import from block, call that, and pass that down to the visit import from block statement. So everything you see here, everything below here that's lowercase is a ctx.uppercase method that gets the context from that. You check those contexts and that tells you whether there's something there or not. Or just pass it down and it'll work correctly anyway. Okay. So that makes sense? Like yeah. These just directly map to, this is the top level node. This is like, it is actually something. And these all exist on the context object in the method. So you have visit import from block, gets a context. All these things are available in the context.
Okay.
And you use those directly, or you just go visit children, and all those ones will get visited individually anyway. Or you can directly work on them in the method itself and don't go any further. If you know what I mean, you can check that import default is not nil, then visit that one or extract what you need from it. Import namespace is not nil, extract what you need from that context. Yeah, it's I'm probably not doing a great job at explaining it, but it's actually really simple once you get your head around it and once you start using it. And there's no substitute for actually trying and just going in CTX dot and you see all these methods pop up and you go, that makes sense.
Of course, yeah.
Yeah, but if you download this stuff and start playing away in the main file and just fuck around with it and break whatever you want to break or do whatever you want to do with it. But yeah, you'll see that everything in the grammar file at the top level is either, you'll see statement list with a lowercase s, and then you have what's in that context underneath it. So anything here, anything after visit is a direct mapping in the parser file. You see it'll be the top level node on the left hand side, and it'll have children underneath with context. So anything you see there directly maps to this. Anything you see under that node is on the context object. So you can access it and decide what you are, what's there, and what's not there. I think that's it.
Yeah. And so if I want to play around with this, is the easiest thing to just like actually clone the project and then start writing stuff in the main file to play around with it?
Yeah. Or you can do it. You can import whatever the fuck you want. These are kind of more examples. Like, but this thing is really, you do need ANTLR in your path. You do need to first run ANTLR, and then you would do ANTLR. I'll show you the command here. Actually, it's here.
Okay, so I will have to run some Java to get it working?
No, that's only if you manipulate the parser.
Oh, okay.
If you manipulate the grammar files. Other than that, don't go near. I only implemented this so if someone does want to make changes and fuck around, because there's a load of things that are wrong, that you get the wrong lettering, certain things are just named wrong. There's just a few things, there's a pointer in the wrong place. This main thing it will post-parse after ANTLR does its job, and it'll correct everything for you.
Okay, fair enough.
And copy in the files it needs. But no, all you need to do is you can go into the parser and use it as a module and just copy what I've done in main, which is where are we going here? Like all the steps are, you get your source code, you pass it to the new JavaScript lecture. This is identical every time. You get a token stream, you pass that to the parser.new JavaScript parser. Then you have the tree p.program or p.statement or p.statement list, whatever is on that left-hand side that corresponds to the visit, whatever you can start there. But just the simplest thing is just start a p.program. It's the top level to go through all your source code. You visit the tree, create a new visitor with a pointer type. Then you visit the tree, and then everything that gets appended in your visit methods to nodes, or if you want to append stuff to expression, whatever you want to do is available in v.nodes or v.expression after. Then you iterate over. But this visit just basically visits every node in the tree. Anything you haven't implemented is the base JavaScript visitor. It's a no-op because it goes back up higher in the tree to that return return nil basically. So anything that's implemented in the visitor type here, all the methods, and like I just split them out because it was just too many in one file. You have the expressions, you have imports, you can like this anything you see in the base that you inherit from. These are all the things that you can possibly implement. And if you go to the, like I said, the variable statement, lowercase v variable statement, you go to the parser file, you'll see what's available under that. Just search for that in the parser file. It'll be on the left-hand side, the higher node, and then all its children are underneath. And then you can kind of go look at their children and go back up and see what they have, and that's basically you can learn. But it's very, like, it's really intuitive. It's basically just JavaScript, like your variable statements or whatever the fuck, but it's very, very simple to use. But anything that isn't implemented on my visitor type, if you want to see like we've done that, visit empty statement or visit variable declaration, just implement those. Change that to copy paste that over, change the base JavaScript parser visitor to v, and just prepend parser dot variable declaration context to that, and that's it implemented. Then you can use that straight away. These are just convenient, so you satisfy the interface. So you can, when you go to parser, there is a quick check here. Let me go into JavaScript parser. Why you need all these methods is because parser. Where the fuck is the parser? JavaScript parser. Now this is about 16 million lines. No, that's the next one. Some of these, like it's not the Go code could use some improvements, but it's like I'm not going to knock someone. There's a lot of work they did in fairness. I'm not going to. But you can see there's 10,800 something lines there already. We're not even at the bottom. So let's say EPT. This is what accept does basically. When we when I showed you that in visit children, you accept the visitor. You go ch. It's an enter parse tree. You do the checking it, and you accept feed. This is what get called. So if you call accept, say, so if you have to satisfy this interface, this means you need to have implemented the method. So if you have implemented the method on your visitor, this gets called. Otherwise, t.visitChildren gets called, which is the base node, which is the base JavaScript visitor, which goes back up and does nothing. So that's why anything you implement, this gets called. Anything you haven't implemented, it falls back to the base thing, whatever. That's why, otherwise, if you didn't have the base embedded, this would be fucking nil, and you'd be calling it nil into panic. That's all it is. That's all that other thing does. Is it tells you what's available, what visitors are there, and it satisfies. It does all of them. So at least then you just implement what you need from that, or overwrite what you need. But it's just a matter of copy paste it. Change the base JavaScript visitor to your visitor type, and then just prepend. You're just importing the type from the parser. And that's it. That's all you need to do, and that's it. You can play around with that and do whatever you want to do.
Great.
But yeah, but this doesn't matter. I'm just showing you what it goes back to. But none of this stuff in the parser, you don't have to give a fuck about it. Where something explodes and you find a bug. All you need to do is go and all you need to do is copy. All you need to do is copy the parser itself. To be honest, you could just download that code, and you can copy the logic that I have in here, which is basically those few steps: create a tree, visit the tree, and then all these, and your visitor type. You could copy paste this and just implement whatever methods, or you can just work off that. I don't care what you do. Probably easier just to use what I've done, but do it a couple of times yourself, so at least you get familiar with how the process works. But like that's it. It's simple. You create your tree, you visit your tree, all the stuff gets appended to the visitor depending on the logic you have, whether you've appended it to the nodes or appended it to whatever you want to do. Literally, like whatever the fuck you do from there is completely down to yourself. Like there is no answer. I don't even fucking know what I'm supposed to do yet, because I don't know what the best way it is. So if you play around it and get an idea and have a look at that ES3 thing, go, yeah, maybe this is a good way to do it. That's fucking super helpful for me, because I'm just one person, and you have more experience with JavaScript and that kind of stuff. I'm fucking odd that I would rather write 60 million lines of code myself than fucking use the library. I'm a masochist. So yeah, but you have a better understanding of how other people want to do stuff than I do. I'm the worst in the world for this. So if you can fucking give me any insight into how you think it would help to work, or how you'd find it easier or whatever, that'd be good.
That might be one place where I can help, is understanding the common man's mind. So
no, but you fucking, like, you have done. I don't do a lot of web related stuff. Like mine is completely different. So I don't understand how people use. Like I've never used WordPress. I've never done any of that stuff. So I have no idea. So that's just, I'm not saying, I don't mean in an insulting way.
No,
I'm just saying that I have no fucking idea about this stuff. Like,
sure.
I genuinely don't. Most of my stuff is back-end stuff or proprietary stuff, and it's fucking a million miles from this stuff. So yeah, so yeah. I just don't understand what's convenient. What's convenient for me is generally not convenient for other people. So yeah, I just have a fucked up way of looking at things.
Okay.
But yeah, but that's it. Yeah, you can play around with this.
Like
I said, these are the steps. But if you just look at what's implemented here, they're just various different things that I was using for testing around. Just copy that, and your visit methods is where the work happens. If you want to put in print statements, which is yeah.
Very cool. So yeah, I'll take a look at this. I'll see if I can get something. So we're thinking for like kind of a first step, if we're going to integrate this into Plenty, would it be like basically what we're doing right now with regex, like commenting out that stuff and changing component signatures and just use it as that aspect for now, where we're actually just like changing that stuff but still running things in V8? Would that be the step number one to pulling this project in, do you think?
Yeah, we could do, to give it a go and see how it works. I could even write a much smaller, like what I have here, the examples here, this is what we implement. Like this never changes, but we can create a really smaller version where it just does the imports, where we just even take the import from part. We don't give a fuck about the rest, really, do we? And maybe do we care about module items maybe as well or something? But we can just operate on the subset that we need. We can just implement those visit methods and forget about everything else, and make it really simple to start with, and manipulate the source code that way.
Yeah, I mean, if you think it's better to do it all as a whole, that's fine too. I'm just asking you what you think is the best first step.
I have no idea.
Yeah, okay.
Because it's all new. I honestly have no idea. That's what I'm saying. I don't know. Like, it's just I've rewritten this I don't know how many fucking times, different approaches, and going because I'm obviously learning as well. I fucking a week ago I hadn't used this, or 10 days ago, so it's all fucking new.
That's cool.
But it can definitely do what we need, and we can have a outside of Plenty as well. But definitely there's like the limitless potential for like transpiling stuff, for post-processing stuff, and like all high, like fucking firing off on a channel loads of jobs for workers. And then, like if you're going to do it, you might as well use Go. We might as well take full advantage of the fact that it's every core and every fucking thing you have in your computer is accessible. So I think we could do some really cool stuff. Like it's definitely not going to be the fastest parser in the world, but the fact that we can do it all in Go, and it's going to be hopefully fairly robust. The fact that we can do a million things at once will make up for any shortcomings in terms of the speed of the parser itself. Yeah. Like, as opposed to, I don't give a fuck how fast your parser is in JavaScript. Sure, it's a single threaded thing. So you're only doing one thing at any one time, whereas we can do literally 20 fucking things at one time. So it's still going to be considerably faster.
That makes sense.
But and I hope we look at it. I keep changing this thing myself, so it's play around with it and see what you think. It's really not that complicated. Like, I probably didn't do a great job of explaining it, but there's just so many little bits to it. But essentially, it's simple. If you just concentrate on the visitor part and understand that your visit method is going to get called when you match that part of the parser. Mm-hmm. Everything under that is available in the context object, and it's totally up to you what you do with it after that. Whether you directly manipulate it there, whether you append it to a nodes list, whatever the fuck you do, whether you write it to a file. Like I said, there's no real, I don't know the answer because there's a different answer for every problem. But hopefully it should hopefully you're somewhat enlightened as to how it works today. But it's
for sure. No, this is super helpful. I think a lot of this comes down to I have to just have a better understanding of how lectures, parsers, visitors, and that stuff works in general. So I think this this is
lectures helpful. Just create all lectures do is lectures create the tokens.
Yep, sure.
And parsers decides what to do with the tokens. That's fucking as simple as it is. You have your keywords and you ignore your white space. Like, when you see this stuff, you can print context at get text and you see there's no white space, there's nothing.
Yeah.
It's like white space is for us. Parsers don't give a fuck about it.
Yeah.
Like, that's all it is. So you extract the noise, you lex it down, and then you decide this is a token. And how it works in that is the hierarchy. The higher up it is the first match it is. Like, sometimes the ambiguity, whatever the fuck, ambiguity even. So it's basically how high up in the tree you come. That's how ANTLR solves it. But that's all it is. Lexer creates the tokens, parser takes in the tokens and decides what the fuck. What should I do with this? Is it a for import statement? Is it a variable expression? Is it whatever the fuck? That's all it is. It's very simple. Like, this people, even the name Lexer doesn't fucking scream obviously, but it is actually really, really uncomplicated.
Okay.
The complicated part is what ANTLR does in the background. It's to be able to give you to make sense of it all, like, and to sort out the hierarchy and all that kind of stuff.
Sure.
But it's really not complicated. You're taking in tokens, you're deciding what the tokens are, and you're manipulating those tokens after that's your output.
Yeah.
Other than that, there's nothing else you need to know about it, really.
That's great. And then, so and you sent me some videos on ANTLR, and I was looking through some of those. Had like this program that was doing like a tree visualization. Is there a way to do that with this as well? Like, is there a plugin?
Yeah, it's GRUN. I think it's. I haven't actually even used it yet. Okay. It's part of ANTLR. If you just download ANTLR, it's a jar file or two, and then you have to set some paths, and that's it, really. GRUN. Yeah, I'm not sure how it works, but maybe you have to make your parser with JavaScript first.
Oh, interesting.
And then run the GRUN over that. I'm not 100% sure how it work with Go. I think that's why I didn't even bother trying, because I'm not sure that it'll work. Well, it definitely won't work, because the GRUN is Java. So maybe you have to, I don't know how it works exactly. I think you maybe have to have the Java binary there already based on what you built and create your parser that way. But you can give it a go. But there's really good ANTLR plugins for IntelliJ, and it's supposed to be for VS Code. And the GitHub repository is still there, but I can't find it in the fucking in their own repository in the Microsoft one, like at the VS Code one, which is not the first time. It happened to me a few times lately. I've been looking for stuff and I just can't find it when I go and search for it.
So I had that problem too. So I'm using a project called VS Codium, which is like the free binary of VS Code. I don't know if you're using that. Are you using regular VS Code?
The Codium one.
The Codium one. Okay, your issue might... So Codium, so I experienced this recently too. I couldn't find the project in Codium. Codium points to not Microsoft's little store. So they point to their own free store. So like if the plugin maintainer hasn't added it to the store, or they haven't linked it, you can't find it. So you can go in and you can change the settings where you're pointing your Codium to, and then you'll be able to find those plugins. Or you can open a ticket with them and say, hey, can you add yours to this, their free and open store?
That makes sense.
So I had the same problem. I was like, why the fuck can't I find these things? And they seem to be available. They seem to be there. I found the website. And, so that's probably what's happening.
Yeah, that's it. Yeah, I should have thought of that, really, but I didn't fucking. Yeah, but because it's happened loads of times. I'm going, what the fuck? Like, I can't. And what's even worse is if I don't know if it happens for you, but if you go to the fucking Microsoft to the VS Code sites and you click the thing to copy, it never fucking works.
You paste it.
It never fucking works. Yeah, I'm pasting stuff and there's like 20 lines of other shit I copied 10 minutes ago. I'm going, what the fuck? It doesn't actually work, and it hasn't worked for the longest time.
Yeah,
good old Microsoft giving us shit again. Like
that started happening to me too. I think that's what's happening, but
no, definitely because I think that would actually be helpful. I think the syntax highlighting and all that stuff, it seems pretty good. So that would definitely help the cause. So maybe get that going as well. But look, as it stands, just copy just take the parser down, or just import the parser in like it's a module there. You can belt away and use it, and you can copy paste the stuff I've done there, or manipulate it directly, whatever the fuck you do. Just play around with it and have a bit of fun with it. But it's really neat. Like, it's cool when you see like that you don't have to do much. Like it's just basically you build the parser through use ANTLR, you build this thing that spits out the Go code, and then you're good to go. You can start parsing all the JavaScript you can want. Like and anything to add new stuff, obviously you have to be careful of the hierarchy of stuff. But if any new stuff comes out, it's just a matter of sticking to that G4 file. Running the code, post parsing with the main.go that I have there, and you're good to go again.
That's awesome.
So it's pretty neat. Yeah.
Very cool.
Coolio. Yeah, so enjoy ANTLR.
Thanks for showing me around what you've been working on. I'm definitely gonna have to take a look and start playing with this a little bit.
Yeah, look at you. It's hard to explain because there's a million different bits and fucking pieces in my own head. I don't even know, because I'm trying to figure out what the best way is. Like, I've already changed my mind probably twice today. Stuff. So
you're experimenting with it for sure. I think that's great. I think that's the way to do it. Honestly, I feel like, I mean, you can plan a little bit, obviously, but once you get in there, like, your plans go out the window anyway. So getting in, playing around and figuring it out, it's great.
I have a terrible habit of I don't. Some people write like pseudocode or write fucking wiki stuff and whatever. I just go in and start writing stuff and I start fucking around with it, and then like 12 hours later, I was still fucking there going, I'm back to the start again. Yep. I have no idea what I'm doing, but I've written 20,000 lines of code and I don't know what the fuck is happening.
Oh, yeah.
But yeah. It's more fun. You learn how things work that way. It's like, like taking things apart. When you're a kid, you take stuff apart and like your watch, your digital watch, and it's always the best way to learn.
Yeah.
Just gut it and see if you can put it back together again.
Yeah.
Then you really learn. Yeah.
And you end up throwing out 90% of the stuff you thought was good at one point. And, but I think that's a good process to go through, right? Like I love when I throw out my old code from Plenty. I'm like, oh, all right, that stuff's no longer relevant. Like, get rid of it. Yeah.
yeah. But that's it. But especially when you're learning something new, because you're not going to get it right. Like it's fucking, you're not going to get it right after many times of trying. But but it is the only way you learn, is to kind of take things apart and dive in. Other than like you can read 50 books about it if you want, but you'll learn more in an hour of fucking around with it than you will. Well, I do believe in read the fucking manual, but if you do get the basic understanding, you can't be just going in and playing with it.
Yep. So do you think eventually, and I know I've been having you on the phone for a while, but do you think like eventually that basically this project would be like a module in like, so if this was going to be turned into a full-fledged like Svelte-like compiler, would this be like a module that you pull into a different project that is the Svelte compiler, or do you picture this project itself turning into a Svelte compiler?
No, this part is, we'll take the parser as the base, and then from the parser we'll create another module, which is what we've implemented to the ES3 version. We'll create the ES3, that will be the module people will use. The parser will stay the same. Obviously people are welcome to use it, whatever the fuck's not mine anyway. I've just copied it over. Yep. But the main plan is to create another module where it's just, we've implemented all the ES3 types, and we either this one, whether it's a linked list or whatever way we implement it, but have all those ES3 types and returning from whatever you pass in, and that's it. So it'll be a full every visitor method will be implemented, and we return all those types. And like that, we start from there. Then we have everything we need straight away, and it's also useful for other people. So maybe they'll contribute, and maybe they'll help us create post processors and stuff like that. So I think that's the way to. If you create something people can use and Go, they'll be more than happy to fucking post process their JavaScript, I'm sure, in Go as opposed to JavaScript itself. So
yeah, it'd be great if more people could write the process, like help write some processors for different things. That'd be great.
And
so
I think that.
Oh, go ahead.
Yeah, go ahead. No, go ahead.
Oh, so and then I remember you showed me two projects, and I'm kind of interested, like how so we're looking right here at the Go JSP, right? I assume that's JavaScript parse. You also had a project called Parse, I think it was. And now is that
great name?
Anymore, or is that just playing around?
No. That was just, that is something I actually use myself, because I'm doing some work for one of the professors in Wharton on some fucking text analysis. And I just needed to extract text from HTML. So that's what I started using that. And I just thought it'd work we could either manipulate that source code in the XHTML Golang library to also recognize the syntax from fucking Rich Harris's the each and if and all that stuff, maybe. Well, it was just to get the script tags for now. So basically, you can pull the script and style, and before we'd gone down the full path with this thing, and then extract the we could still use it to get to the style, and then work on the imports. That's the first thing we could do, just to see if this works.
Gotcha.
But yeah, that's all that is really. It's just you pass in whatever tags you want, and if you want to go the full depth, you pass in true as the second flag, I think, or something, and our secondary argument. If not, it just takes the root one, so to get the root style and the root script, if you pass in script and style, and then you have the attributes and stuff like that, which is actually something else that you need from Svelte. They see the parse modules differently to regular script thing. They have their own little create module, whatever. So I don't know what they do exactly, but that's what I'm going to try and mimic first today and see how that goes.
Okay.
The only weirdness is that fucking code red thing he was doing down the bottom. I was like, what the fuck is that? And then I figured out, found a repository. Yeah, it's just like a leading X or leading T or something, which is more stuff that your editor has to understand. But that's it. Yeah, we can do the same kind of thing. Okay. Basically, it's what the code does. We're doing the same. All it's doing is manipulating. It creates a little tree, and then you manipulate it like this. And his was .code, and then it showed you back the code after you made your changes. So which the CS3 idea will work the same way. Whereas like if you had, say, an expression, you instead of doing PDR program, just do PDR expression. It'll put that expression, and then you can manipulate that expression, and then hit code, and then it'll output the changes you've made. I don't know why that's not working. I think it may be because I switched around to non-pointers in something in the list there, but I'll have to double check that. But that ID.import from should be it should be oh no, I know what it is, the fucking expression. Yeah, balls. Yeah, no, this won't work. because if I commented out the expression part, bet you 100 fucking quid this will work now. Just give me 1 second. The children, I bet that's what it is, because I'm hitting 2 different types. It's probably will panic now to make things even worse. But anyway, see if that works. I'm trying not to panic. Actually, it should be, yeah. Let me get rid of this 6 method commented out. Just, yeah. See, that's the panic there because it's the wrong type. I'm back. We've done a type assertion up here somewhere. Is it expression sequence? All right. Where is this? We'll just do return feed of as a children. Because it's an import expression, so that's just getting hit first, and that's the first type I check. So this is the other thing. If you want to operate and just create like if you didn't want partial bits of statements, you have to find the highest node in the tree for that particular subset. So if you wanted like an import that starts up higher, there's a lot of overlap. So I think the simplest thing is just to do the ES3 thing and create like nodes all the way down, and then you can extract the little bits that you need that way. Because if you start trying to create, that's what I started doing first, was say I went to the import statement and I said of visiting children, I was trying to see what you are, and then can I pull all these pieces together, but then that's fucking, you might have an overlap with something is 2 things, it's an expression and it's something else, and then you don't know what the fuck. So I think doing the ES3 way, where you just let all the nodes come along and then manipulate them, because you're never going to manipulate, I don't think you're ever really going to manipulate the whole part of it. It's like the letter and what it is and the value. You want a little subset of it. You want to know what its parent is, maybe, that it is a declaration, but you're only manipulating a little bit down further, like the next node. So I think if you had a linked list where you had, or even a double linked list where you had a back and a forward node, so you'd know what the parent was in the back node, and then you know, okay, my next node is my child, and it's either this, that, or the other, and we can go back up the tree and back down the tree. I think that maybe would be the way to implement this. Instead of a slice, create a linked, doubly linked list, you can go back and forward to your parent and your child. So right now, if it's an import statement, I know my next one's either an import default or it's whatever, because it's going to be in the correct order. That it's like if you have like export default, you know, the next one is going to be default or whatever the fuck it is. These are all exactly in sequence.
Sure.
So I think maybe that was one thing that I was thinking of, was maybe it would be to have either probably a double linked list where you can go back and up the tree. You can go to the parent and the child, and then you can decide what you are, and then you don't have to start trying to get the highest level node and then, you know, create like I was trying to do there with creating the module items and the default items. Just visit the children, let the children get spat out as individual nodes, and then as you recurse and you go down the tree, you visit the tree. When you're a top level node, you're a import parent. And then you can visit his children, whatever. Yeah, I think that's probably the smart way to do it, is create some sort of tree where you can visit nodes that way. I think probably the best way to do it, and it'll mean it's probably the way I think most parse trees are implemented anyway. I think most people view it that way.
Sure. Okay.
So, right. But again, I don't know. It's fucking, if you come across something that you think is a better idea.
Yeah. I don't know if I would, at this point, if I would know what is a better idea, but I'll definitely share my thoughts with you as I...
Oh, yeah, no, when you're using it, yeah, go to it. What's the fucking type here? Oh, imports. It should be imports. All right. The joys of live coding. Yeah, that's
I know, right?
Imports. Imports. Some fucking imports. This is a side effect of. Okay, we'll do. So I changed to an imports type at the top level, and then all its children were import declarations. So this is what's going on. So we'll say, where are the details here? Children. 0. And that is a fucking. Import declaration, I think. They're already. No, we don't even have to do the assertion, because that's what I am. So yeah, I'm holding you up now as well. I just want to just show you this working, because this is kind of this is how it's going to work, because you obviously. It returns nodes as the vnode type. Certain things like the type and the code are always there because it satisfies the interface, but this is where it gets the interesting, where you decide what type exactly, what You are all no V nodes, but then after that you have to decide what you are, which is type assertions. So here we go. So hopefully this time it actually fucking works. Yeah, see, this is beforehand. Import default, export from, just forget about this, is probably even arseways in terms of how I've written it here, but so we've manipulated the import from to whatever new path.
Sure.
We've manipulated the alias name for the first module items to whatever name.
Yeah.
That's basically all it is. So then when you hit v.code down here, you've done the translation. But you can also manipulate, you can get the offset and you can change that bit in the file directly. It's whatever. The code is just kind of a nice way to show you that this is how you transpile something. You take it in, like you could have one little bit of code, like that's what the code, this could do what the code red stuff does in. You take an expression, you manipulate it, you change it and hit v.code, and then you have the transpile code into whatever.
Yeah.
So that's so you can do all that stuff with the ES3 thing. You can extract little bits and do what code red does in Svelte, or you can visit the whole tree and transpile whatever. You can take individual bits out or whatever the fuck. Like it's just up to yourself how it works.
Yeah.
But that's basically it. So you decide what you have. This one has children. Like you go over all the children and do whatever else. You can see what child it is, whether it's a default import or like whether it's, if it is module, has module items, isn't it nil, and it has module items, and you'll have 0 to n or 1 to n module items, that kind of stuff. So you can get really fine-grained manipulation of the tree or the nodes, and that now that it actually works. There you go. So that's it. Yeah, it's pretty straightforward. You take whatever you want. These are all pointers, so anything you could even go like this dot import from directly, like you can operate on structs directly when they're pointers. If not, you'd have to take it out, you'd have to assign something, and then you'd have to reassign it. That's the beauty of working with pointers to structs. You can, or even like if you're incrementing a key in a dictionary, you can't go plus plus. Sometimes you'd have to go, or something on a struct field, you can't go like this, like plus plus. If this was an int and you wanted to go plus plus on it and it wasn't a pointer, you couldn't do it. You'd have to extract it first, because obviously if it's not a pointer, things move around in memory, so you're not necessarily pointing to the same objects. That's why I always prefer to have, it's a little bit more difficult because you have to check things are nil, because things can panic. The other way you don't when it's just a type, because you can operate it because it's the 0 type of it, so it actually is, it feels are accessible. But with pointers you have to do the check, but that just means you can do, instead of this IM here, I could go IM dot fucking import from dot equals to whatever the fuck, and then I wouldn't need to assign anything to anything else. I could do the same thing down here. IM dot modules from not equal to nil. Yeah, it's not. It doesn't seem like a lot there, but it makes more concise code when you want to manipulate stuff. Yeah. It's very easy. You can do it all in one hit. So yeah.
Yeah.
That's it. That's the only other thing there. So yeah.
This is great. I can definitely see the potential here. This is, I mean, it's huge. It's just like it's if we implement this fully out, like obviously we are now doing plenty a very different way, right? Like we're actually like manipulating and building our own compiler way instead of we're not running JavaScript anymore. Like
not at all. Yeah. It's just which is the fucking mecca.
Yeah.
So you can still do all this nice stuff without ever touching JavaScript.
Yep. And then so I would think that even like you said, even maybe if this isn't the fastest parser, I would think that parsing and manipulating this would be much faster. Even though V8 is crazy fast, it'd be much faster than running all that JavaScript and doing that process in JavaScript.
Yeah. Plus we can do this all concurrently. Yeah. Like it's not a case of, we don't have to worry about anything else. We can just blast this all off, and we've got 20 files to do. Yeah. Go to 20 fucking parsers and off you go.
Yeah. I mean, this is crazy. I feel like for Plenty, this is huge, but I could picture this project being picked up by several different frameworks.
If we make it right. So I do think it's worth investing the time in the ES3, even though a lot of the times people do stuff. But I do think it's nice the way it's done. It's a top level program node, and it's almost identical the way I was doing this with the V node. So I'm on the same page. It works for me. Obviously, a lot of other people think it does as well. Yeah, because a lot of people use it. But I think if we implement all those types, and then we can. Once you have all those types, then you can even create your tree with the visitors. You can, like, all those types that live there on this module, and you can either create your tree completely, or you can implement partial bits or whatever. Like it'll still leave it really open to interpret it however you want. You can operate in subsets of trees. You can do whatever you want with it. But everything will be there that you need. All the types will be there, and all the visitor methods are there on the base node. And again, you'll just implement whatever base bits you want. And so it's I think that definitely doing the ES3 stuff and just getting all those types implemented and matching them up to the source. And once we have all that done, then you can do whatever the fuck you want with it, because you've basically got everything covered. You've all bases covered. So you can manipulate whatever, as much or as little of the tree as you want, and extract what you need.
It's awesome.
You can see it's simple. Like it's And it's nice because they're like alias name, .identifier name. It's very, like, it all makes sense. You just read and you see what it is. You take the module items, you get the alias names, you get the first one, and you're changing the identifier name to that. That's it. Like, it's not, there's no magic. Like, it's just does what it says on the tin.
Yeah, so. That's great. No, this is super cool. I appreciate you walking me through all this. I'm definitely gonna have to play around with it some more.
Yeah, no, hopefully it all makes sense, but it won't make total sense till you fucking play around with it anyway. But you'll see that, like, I can't express how it's really straightforward. Like, it wasn't straightforward to get it all working together because bits that are broken in the original runtime even. But yeah, but in essence, it's really simple. Yeah. It's just a matter of manipulating, looking at the grammar, and whatever you see in the grammar at the top left-hand part, everything below is in the context node, and you decide what you want to do with the context from there. Yeah. Sometimes the context will have actual textual values itself. Sometimes it's just a higher node. It just signifies what it is, and then you can play around. But it's, like I said, anything in the higher node is the context object in the visit method, and that's what your visit, whatever the fuck name with the pound sign, it's going to be there, visit that, and then anything below there, or even if you don't visit it on the left, its children are there, you'll get that type, you get access to it. You'll go to lower down the tree and you'll see, okay, there's no visit method on this, but this appears lower down, so I'll go back up the tree and see, oh, this is what it is, and this is what's potentially there. So yeah, it's really straightforward. Anything with a question mark is optional, anything with a pipe is either or, but one of them is definitely there, and then I think it's anything with the star means that there can be 0 to, I don't know, is it 0 to 10 or 1 to 10, but yeah, there's a few little things in the syntax, but it's basically like regex. It's just like, once you understand regex, you'll understand everything in the grammar. It's nothing too complex. So.
Huh. Cool. That's
so yeah, so have fun with it anyway.
Yeah, thank you. Yeah, I'm excited. I'm excited to play around.
Yeah, you'll have fun. It's amazing when you see how simple it is, and you're manipulating stuff. You can kind of go, yeah, you can see so many uses for it. You're going like, fuck, this is this is pretty neat. Yeah, there's so many things that I want to do that I can't do right now. But this will do it. Like,
yeah, for sure.
Yeah.
Great. So I recorded this little walkthrough. Do you mind if I post this on YouTube just so like-minded people can take a look at this?
Yeah, you can if you want to, although they might be more confused after.
I think having more materials out there is always helpful, so I think that's... Yeah, cool.
Although maybe we'll do a better one. Maybe we'll actually walk through and maybe structure it a little bit better. I'll come with some sort of a plan, and then we'll...
We can do we can do a couple of them. I think I'm a big believer. Maybe it's the wrong approach, but I think just like getting as many materials out there and hitting people at different points in their interest, because there's going to be some people who want deep divey stuff and want to hear exactly what was said. So
I think maybe with when I'm a little bit more of an understanding of what we're fucking doing.
Yeah, sure. This will change over time, I'm sure. But I think there's going to be people that want to help inform that. So hopefully there'll be some folks that maybe we can get in touch with that would want to help with this project. That'd be cool.
Yeah, because from now on, I think like Bard, there's going to be bugs, there's going to be issues with the parsing, and that's true for every fucking parser that's out there. I don't care what, even if it's Acorn. But in terms of it, now it's just a matter of structure. I think we use ES3 as the base for how we implement stuff, and the types, so we'll name them the same way. Like that's most of the work for the next part is going to be getting them implemented and get those bits done. You'll be able to do it, no bother. Guarantee you have to spend 2 or 3 hours with this. You'll not even an hour with this. You'll see how you can implement the types. Because they all map directly to something, and they all have children. So if we just create it like it's a doubly linked list or something, which I can implement simply, then it's just a matter of each one that should return a type returns a type. When you get to that visit children method, you can have 1 to n types, maybe whatever way it works. It's slightly different for all of them, but you do your select, you do your switch statement, and then you appropriate cases, do the appropriate action, and then you do your appropriate checks on the parent, whatever you're doing, and it's pretty straightforward.
Awesome, very cool.
All right, well, enjoy.